This is CPM Calculus Chapter 3, number 18. Here we're asked to evaluate each limit. If the limit does not exist, say so, but also state if y is approaching positive or negative infinity. Okay, so A, we have the limit as x approaches 2 of this function here, or this expression, okay? So we have x squared minus x minus 2 over x squared minus 3x plus 2. So the first thing we should do is see if we could plug in 2, since we just have a value, and see what the function is at x equals to 2. So if it's defined already, then it's great. So we have 2 squared minus 2 over 2 squared minus 3 times 2 plus 2. So this one's 4 minus 2 minus 2. So 4 minus 2 over 4 minus 6 plus 2. So that's equal to 0 over 4 minus 6 is negative 2 plus 2 is 0. So this right here is not a number, right? It is indeterminate. So undefined. Okay. So whenever we get 0 over 0, we cannot just say the limit's 0, because 0 over 0 is undefined. We need to do more investigation. Means more investigation. Okay? So we know that this doesn't work, so let's see if we can factor anything out. So let's try again. So we have the limit as x approaches 2. So can we factor the numerator? Well, yes, we can use this method where we multiply two numbers to get negative 2 and add them to get negative 1. And that would be negative 2 and 1, right? So it's going to be x minus 2 and x plus 1 over, and then again you can use this method, multiply two numbers to get positive 2 and add them to get negative 3, and that would be negative 2 and negative 1 over x minus 2 times x minus 1. Okay, so we already know that our function is undefined where the denominator equals to 0, and at 2 it's equal to 0, right? We plug in 2, we get 0 in the denominator. So it's undefined there, but that doesn't mean the limit doesn't exist, right? Because here we can see if we factor this, these cancel out, and the limit as x approaches 2 is the same as x plus 1 over x minus 1. Is the same as this, okay? So that's equal to, now plug in 2, is equal to 3 over 1, or 3. Okay, so here we get a value, and we're happy. The limit does exist, and it equals to 3. And remember that if it's undefined at x equals to 2, right? So here's x equals to 2. We know it's undefined here, right? But since the limit exists, there's just, and here's 1, 2, 3. It's going to be a whole, right? It's not going to be an asymptote. So on the left, we're going to go here. On the right, we're going to go whatever here. This, I'm just talking about this part right here. There's a hole at that point. It is discontinuous, but there is a limit that exists because as we approach it from the left and the right, we approach to the same value. Okay, let's go on to B. B is the limit as x approaches 5 of square root of x minus square root of 5 over x minus 5. So if we plug in 5, we can see right away we get square root of 5 minus square root of 5 over 5 minus 5, which is 0 over 0. Again, we cannot leave this as an answer, so that's a sad face. This is our indeterminate, so we have to dig deeper. So that's a happy face, because we know what to do. Okay, so dig deeper. What can we do with this? We can do stuff with this. Okay, so we have a square root of x and a square root of 5. Okay, let's leave that in the numerator. Okay, and we have an x and a 5 in the denominator. Well, you notice that square root of x here is just square root of x squared, right? And 5 is square root of 5 squared. So let's rewrite it as square root of x squared minus square root of 5 squared. Okay, now what do you notice about this in the denominator? It's the difference of two squares. Okay, and we can factor that now. We still have x, square root of x minus square root of 5 in the numerator. Now, the difference of two squares allows us to separate that as square root of x minus square root of 5 times square root of x plus square root of 5, right? And now we can see that this in the denominator is going to cancel out with this in the numerator. So we're left with the limit as x approaches 5 of 1 over square root of x plus square root of 5, right? Now if we plug in 5 there as our x value, we're going to get 1 over square root of, now we plug in 5 plus square root of 5. Well, that's equal to what? 5 plus square root of 5, you have two of them, 2 square root of 5, right? We're happy with this is now our limit, it exists. We just want to get the square root outside of the denominator, so we multiply by square root of 5 over square root of 5, because we don't like square roots in the denominator, so we're left with square root of 5 over 2 times 5 is 10. Okay, so this is the limit for part B. Okay, now let's go on to part C. Part C, we're asked for the limit as x approaches 2, now this is from the left, right, of 2x plus 1 times x minus 5 to the 6th power over x minus 2 to the 7th power times square root of 9 minus x. Okay, so if we plugged in x in the denominator, right away we're going to see that this is equaling 0, right? It's going to be something over 0. Right here we're going to get 4 plus 1 is 5. We're going to get 5 times 2 minus 5 is some number, right? So we're going to get some number over 0. So is that going to, so what is that going to be? Over 0, well, this again, we can't just say is undefined. We have to look deeper, okay? So the limit we know doesn't really exist because there's going to be at x equals to 2, right? 1, 2. There's going to be now undefined right here. There's probably going to be a vertical asymptote. Actually, there is because we can't simplify it anymore. And when x approaches 2 from the left, right, is that going to be the same as when x approaches 2 from the right? So we're approaching it from the right and from the left. When we get to 2, right, here's our value 2. Where is x going to be approaching? If it's approaching up here, right, from the right, but from the left it's approaching down here, well, that's what we want to know. We want to know where it's approaching from the left only. Okay, so for this one, you can do it in a few different ways. You can look at, well, from the left, what am I going to have right before 2? Well, from the left, right before 2, I'm going to have 1.99999, right? 1.99998. 1.5 is here, 1 is here, 0 is here. So from the left, you can start looking at, well, what about when x is 0? What about when x is 1? What about when x is 1.5? What about from x is 1.999? Because you're approaching 2 from the left, okay? So you can do it that way, and you can plug in different values and see that. Or you can bring out your calculator, and you can graph it and see it that way too. So let's use our calculators. Okay, so I'm graphing, and in the numerator I have 2x plus 1 times x minus 5 to the 6th power, and the denominator, so divided by, I have x minus 2 to the 7th power, x minus 2 to the 7th power, times square root of 9 minus x. Okay, so let's enter that. Yes, that looks like what I want it to look like, right? And then let's graph it. Okay, come on, calculator, go, go, go. So it's starting here, negative infinity, like x goes up, it goes down, right? And then it goes something over here. It starts up here and it goes down. Well, where do we want to look again? We want to look where x is approaching 2 from the left. So let me zoom in. Okay, so let's zoom in. And let's go to where x is, where x is 2, or around there, right? Because if I zoom in around there, that's going to be most helpful. Busy, busy, busy. Okay, so here, see this point, my little cursor there is at x equals to 2. So now let me trace F3. So e to 11 means really big number, but I'm 2 point something, so I'm the right of 2. So how can I get to the left of 2? Okay, so now I'm at x is 1.6, and my y value is negative 1 times e to the 6th. Okay, so it's a really big, e to the 6 means times 10 to the 6th power. So that means 1 point this, or times 10 to the 6th, or you can move the decimal place to the right 6 times. So it's a big number, right? So if I keep getting if I keep getting closer to x, so now x is getting closer and closer to 2, this number is growing toward what? Negative infinity. Wow, that is a really big negative number. Okay, so once I get to the right of 2, it's now a positive infinity number. So I know that over here my graph is going up, and over here from the left it's going down. Okay, so let me put away this calculator. So I know that the limit as x is approaching 2 from the left is equal to infinity. Okay, the limit as x approaches 2 from the left equals to infinity. So when you're talking about limits, when you're going to infinity, then people often say it does not exist. Okay, or you can say infinity as long as you understand that, infinity is not really existing. Right, the idea of existing. Okay. Now let's move on to part D. Part D asks us the limit as x approaches infinity of this, okay? So we can't really plug in infinity, right? Because if we plug in infinity, that doesn't make sense. So what are we going to do? We're going to actually look at this expression and see what happens as x gets bigger and bigger and bigger, like infinity. So we're kind of conceptually try to understand this, okay? And you could also graph it and look as x goes on and on to the right and see what happens to the function. Okay, so let's do this algebraically. So let's simplify this. As x approaches infinity, in the numerator it looks nice, 4x squared plus 2x plus 9. In the denominator, let's factor this negative all the way through and put the x squared term in the front, so we get 6x squared minus 3x minus 2, right? I just factor the negative sign, and I get this. Okay. So, before I continue, let's just look at the limit as x goes to infinity of 1 over x, right? We know that as x gets bigger and bigger and bigger, right? X gets bigger and bigger and bigger. 1 over x is like this, right? Oops. Right? These are asymptotes. As x gets bigger and bigger and bigger, 1 over x goes to 0, 0, 0, 0, right? It approaches 0. The limit as x approaches infinity of 1 over x is 0, okay? So what is this limit? Well, we know that the biggest power is x squared, right? And so what we talked about before is we can just ignore what's to the right. Well, if you want to actually not just ignore it, you can do something else. You can look at now the limit the same way, but let's multiply the top and the bottom by 1 over x squared. 1 over x squared. Okay, so if we multiply that and the top and the bottom, that's like multiplying by 1, right? okay? And the reason why I chose 1 over x squared is because the biggest power is the same and it is x squared. So if I do 1 over x squared, I'm going to get rid of x squared next to 4, right, and 6. So let's simplify this. So if I distribute this in the numerator, I get 4x squared over x squared is just 4, because x squared cancels out. Then I get 2x over x squared is just going to be 2 over x. And then I'm going to get 9 over x squared, right? That's in the numerator. In the denominator, I get 6x squared over x squared, which is just 6, minus 3x over x squared is 3 over x, minus 2 over x squared. Okay, so before I continue, I want to again touch base on this. The limit as x approaches infinity of 1 over x is 0, right? And 1 over x squared, right, as x gets bigger even faster, it's still going to be 0, right? As this in the bottom gets really, really big, this value gets really, really small, and it approaches 0 as you're going toward infinity. So taking that into consideration, when we're taking the limit as x goes to infinity, well, we know some constant over infinity is going to become 0, right? It's going to approach 0. Some constant over x squared is going to approach 0. Some constant over infinity is going to approach 0. And some constant over infinity is going to approach 0. So this is going to be 4 plus 0 over 6 minus 0 minus 0 when I take the limit. Okay, so I'm no longer saying the limit. I already took it, right? 4 doesn't change, so we just get 4 over 6, which simplifies to 2 over 3. Okay, the trick, again, is we look at the biggest power in the numerator and the denominator. If they are the same, we ignore everything else but the coefficients, right? So that's equal to 4 over 6, which is what we get right here. And this is why we can do it. We can multiply the top and the bottom by 1 over x squared to cancel things out. Okay, so this is the answer for our limit as x approaches infinity. And this ends CPM Calculus Chapter 3, number 18.